Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our mini project ECE354, the pedestrian traffic light. Before I go through to our mini project, I want to introduce our group member. First, Muhammad Iman Shahmi bin Abdul Manan. The second, Wan Muhammad Shahmi bin Wan Abdul Manan. The last one is me, Muhammad Alif Najmi bin Iswandi. Next, project description. The project is a pedestrian safety light system for a straight road with no junction. It allows pedestrians to cross safely using a push button. Normally, the traffic light stays green for vehicle and red for pedestrian. When the button is pressed, the traffic light turns yellow for 5 seconds, then red for 30 seconds, allow pedestrian to cross. A buzzer provides an audible signal, slow beep for the 15 seconds and faster beep for the last 50 seconds. The warm time is running out. The system uses LED for clear visual, ensure safety and accessibility.
Now, let's take a look at the circuit diagram. The system is built around the Dragon board, specifically the HCS12 microcontroller. It receives input from a push button which is connected to port H0. This button is used to trigger the pedestrian crossing sequence. The Dragon board then controls multiple outputs. For vehicle traffic lights, we have port B0 for the red LED, port B1 for the yellow LED, port B2 for the green LED. For pedestrian signals, port B4 controls the red LED, port B5 controls the green LED. In addition to the LEDs, the system also includes a buzzer to assist pedestrian. The buzzer is connected to port T5 and activates when the pedestrian signal is green. These setups ensures clear signals for both pedestrian and vehicles, making the crossing process safe and efficient. Now, let's walk through how the system works. The process begins with the system in its default state, where the vehicle traffic light is green and the pedestrian light is red. At this stage, vehicle continues to move and pedestrian must wait. The system continuously checks if the crossing button has been pressed. If not, it remains in this state. But when a pedestrian presses the crossing button, the system initiates the crossing sequence. First, the vehicle traffic light changes from green to yellow, signaling drivers to slow down. This yellow light stays on for 5 seconds. Next, the vehicle traffic light turns red. At the same time, the pedestrian traffic lights turn green, allowing pedestrian to cross safely. And following along, a buzzer is also activated for 30 seconds, providing an auditory cue for pedestrians. After the crossing time ends, the system resets. The vehicle lights turn green and the pedestrian light turns red, and traffic light resumes as normal. These cycles repeat every time the button is pressed, ensuring a safe and efficient pedestrian crossing system.
Now I'm going to present the coding with comments. So this segment, we will configure input and output ports that will be used in this program. First, the command moveb $$FFDDRP will set the port B as an output by assigning all bits to 1, which is useful for controlling the LEDs. Beside DDRJ sign $02 will configure the PJ1 as an output, and bclear PTJ sign $02 will set the PJ1 to 0, which likely will act as a reference in the circuit. Then bclear PTH sign $01 will configure port H0 as an input, which is useful for the push button signals. Finally, beside DDRT sign $20 will configure the port T5 as an output, which is used to control a buzzer. Next, in this forever loop, move B #sign $14 port B instruction is used to turn on the green vehicle traffic light, which is PB2, and red pedestrian traffic light, which is PB4. So the buzzer is turned off by writing instruction bclear PTT sign $20. After that, the program will check the PTH for an input signal. So when the pedestrian presses the button, the program changes the port B to sign $12, which turns on the yellow traffic light PB1 while keeping the pedestrian red light PB4 on. The system then will wait for 5 seconds before changing the port B to sign $21, which will turns on the red light for traffic light, which is PB0, and will turns on the green pedestrian light, which is PB5, allowing the pedestrian to cross safely. In buzzer on loop, the PTT sign $20 will be set, which means the buzzer will on for 1.25 seconds before the PTT sign $20 will be clear again, which means the buzzer will off for 1.25 seconds. One cycle of beeping takes 2.5 seconds, and it will repeat for 6 times for a total of 15 seconds before jumping to buzzer on 1. In buzzer on 1, the buzzer will on again for 0.625 seconds, and then it will off for 0.625 seconds, and the one cycle of beeping for buzzer on 1 takes 1.25 seconds, and it will repeat for 12 times for a total of 15 seconds before jumping to branch loop forever. After the program jump to branch forever, the green traffic light PB2 and the red pedestrian traffic light PB4 will turn on again. This section is all the delay that is used in the program. Counter 0 subroutine for 0.625 second delay. Counter subroutine for 1.25 seconds delay. Counter 1 subroutine for 2.5 seconds delay, and counter 2 subroutine for 15 milliseconds delay.
Now, let's talk about the innovation in our system. For innovation, we added a buzzer. This code snippet controls the buzzer operation to enhance pedestrian safety. The buzzer is connected to pin 5 of port D and provides an audible signal it's safe to cross. In the first section, the buzzer follows a 2.5 second cycle. It turns on, waits for 1.25 seconds, turns off, waits another 1.25 seconds, and repeat this cycle 6 times, totaling 50 seconds of beeping. In this section, the beeping pattern changes to a faster 1.25 second cycle. The buzzer turns on for 0.625 seconds, then off for another 0.625 seconds, and repeat this 12 times again, lasting 50 seconds. These alternating patterns help pedestrians, including those visual impairments, recognizing when it is safe to cross.
Discussion of our mini project. The pedestrian traffic light system improves safety by allowing pedestrians to cross with a push button. The yellow light lasts 5 seconds before turn red for 30 seconds, give time for everyone to react. A key of feature is buzzer, which help visual impaired individual. It beeps slowly for the 15 seconds and the faster for the last 50 seconds to signal when time is running out. The system could be improved with sensor-based timing instead of a fixed 30 seconds and solar power backup for reliability. Overall, it makes crossing safe and more accessible. Last of our presentation is conclusion. The pedestrian traffic light system improves safety by allowing control crossing with a push button. It reduces unnecessary traffic light stop and includes a buzzer to help visual impaired individuals. Clear visual and sound signal ensure safety and efficiency. Feature upgrade like adaptive timing and solar power could make it even better. Overall, it's practical and effective solution for safe crossing.